The next 20 years will bring a new era for understanding and protecting our home planet. The knowledge we are presently gaining about the Earth system will dramatically improve the quality of our lives.
And now for the forecast. There are several major environmental alerts affecting our world. Let's begin with Hurricane Gary in the Atlantic. As predicted, the outer rain bands of Gary generated 3 inches of precipitation overnight for Havana, Cuba. Gary is continuing to strengthen off the coast of Florida. The Weather Service's high-resolution ensemble models agree that the storm will not strike Orlando, but will move inland near Charleston, South Carolina. Here's the forecast loop. Now, we're looking at the best and worst case scenarios which could affect the East Coast. In the worst case scenario, we'll receive 8 inches of rain as Hurricane Gary stalls over Virginia Thursday night. In all cases, we expect clearing by Saturday. We expect lowland flooding and stream flooding in the Chesapeake and Potomac basins. Additional flood information can be found on the Emergency Information webpage keyed to your location. We expect several days of severe air stagnation in the Northeast before the hurricane reaches that area. Air quality models predict ozone and particulate levels in the unhealthy range. If you suffer from respiratory problems, you should check the air quality website. In other environmental news, dust storms are predicted to move out of North Africa in the next week, affecting southern and eastern Europe air quality. An even larger event is predicted to develop in northern China later this week. Medium-range climate models show the current East Pacific Ocean warming will develop into a full-blown El Niño within 6 months. There's a high probability that drought conditions will occur in western North America and throughout South American rainforests. Updated soil moisture and crop forecasts for the next 6 months can be found at agriculture websites keyed to your location. Space radar indicates increased stress on faults in the California Mammoth Lake area. Earthquake models predict 5.0 to 5.5 magnitude tremors within the next few weeks. The USGS website has additional information on the earthquake forecast and safety procedures. Alaska's Mount Spur continues to erupt. The eastward drifting plume poses an aviation hazard to trans-Pacific flights. International flights have been rerouted around the plume. Be sure to check airline schedules.
What you have seen is our vision of the future. We will be using advancements in Earth science and observations for many practical applications. We will be making accurate predictions of climate change, crop production, energy and water use, disease outbreaks, and other natural hazards. What will it take to make these predictions? More observations of the Earth's environment are needed. More accurate measurements of winds, water vapor, temperatures, aerosols, and soil moisture will improve our forecasts. At the Lagrange points, Sentinel systems using lightweight holographic telescopes and interferometers will image the whole globe. From geostationary orbit, high-resolution optical and infrared sensors will monitor clouds, water vapor, ozone, and aerosols. In near-Earth orbit, LiDARs will measure winds, cloud heights, and ocean circulation. Microwave sensors and radars will measure soil moisture and ocean salinity, while synthetic aperture radars will measure earthquakes and rainfall. In the atmosphere, robotic aircraft will be deployed into severe storms. At the Earth's surface, a linked network of global sensors will monitor radiation, air pollution, precipitation, soil wetness, and stream flow. Beneath the ocean surface, undersea floats and robotic vehicles will measure salinity, temperature, and currents. We also know that better environmental predictions require realistic, high-resolution models. Prediction models assimilate all available satellite and ground observations to begin a forecast. The models then blend in information about ocean circulation, surface hydrology, cloud dynamics, and other processes. High-resolution prediction models of the future will produce precise local forecasts. These models will use and generate an enormous amount of data. How will future computers process and distribute this flood of information? As fast as computers will be by 2020, a single computer will still be thousands of times too slow to make accurate, detailed, local predictions. Forecast models of the future will run on teams of computers distributed across high-speed networks and linked to satellites through microwave and optical relays. Models on these distributed computers will be coupled to perform real-time local predictions. The output from the various prediction models will automatically be fed into models of flood prediction, crop forecast, transportation routing, energy use, as well as economic impact. These predictions will be available worldwide, and you will be able to tailor the output from these models for your specific needs. You'll be able to call up a personalized forecast from anywhere on our planet. This is our vision of the future. This vision harnesses the world's scientific and technical knowledge to protect our planet and improve the quality of our lives. Working together, we can make this vision a reality.